All right, today we're diving into some really cool tech. It's all about turning a huge problem, waste heat, into a power source. We're talking about tapping into this massive, invisible river of energy that right now we just let disappear into thin air.
And to really get a sense of the scale here, just look at this number. It's pretty staggering. More than half, yep, over 50% of all the energy we generate across the entire planet is just lost. It's not lighting up our homes, it's not moving our cars. Nope, it's just escaping into the atmosphere as heat.
I mean, that is a mind-blowing amount of wasted potential, right? So it just begs the question, what if we could actually grab some of that back? What if we could put it to work?
And this is where the big idea really clicks into place. We need to completely change how we think about this. It's not waste heat, not really. It's an absolutely massive, completely untapped energy resource just sitting there, waiting for us to figure out how to use it.
So the big question is, how do we actually do that? Well, there's a technology designed specifically for this exact kind of heat recycling. It's called the Organic Rankine Cycle, or much easier to say, ORC.
Now, I know Organic Rankine Cycle sounds super technical, maybe a little intimidating, but the Rankine cycle part is just the basic process that steam power plants have used forever. The ORC is just a special twist on that. Think of it like a self-contained engine that grabs low-temperature heat and spins it into clean, useful electricity. It's basically energy recycling at its absolute best.
Okay, so let's get into the nuts and bolts. How does this thing actually work? Well, the easiest way to picture it is to think of a classic steam engine, but with one really important modern twist.
The whole thing breaks down into 4 simple stages that just repeat over and over again in a continuous loop. You've got evaporation, expansion, condensation, and then pumping. So at its heart, the idea is super simple and totally proven. You take a heat source, in our case, waste heat, and you use it to boil a liquid. That liquid turns into a high-pressure vapor, and that vapor is what pushes against a turbine, making it spin. The spinning turbine then drives a generator, and boom, you've got electricity.
But, and this is the key, here's the secret sauce. This is the one detail that makes the ORC so incredibly good at this job. Unlike a normal steam engine, it doesn't use water.
And here's exactly why that's such a big deal. You see, water, well, it needs to get really hot to boil, right? 100 degrees Celsius, 212 Fahrenheit. Most waste heat just isn't that hot. It's more lukewarm. And that's where the organic part of the name comes into play. Instead of water, these systems use a special organic fluid. Think of something like a refrigerant. These fluids have a much lower boiling point, so they can turn into vapor using that lower grade heat, capturing energy that a regular water-based system would just totally miss.
So this ability to work with lower temperatures, it makes the ORC incredibly versatile. It opens up a whole world of possibilities. Which leads to the obvious question. Where are we actually putting this technology to work in the real world?
Well, the applications are all over the place. I mean, you'll find them in heavy industries like cement factories and steel mills, places that are just pumping out enormous amounts of heat. They're used in geothermal plants to tap into the Earth's own heat. And get this, they're even used to capture the heat pouring off the servers in giant data centers. It literally turns a huge cooling problem into a brand new power source.
Okay, so the engineering is obviously very clever, but let's zoom out for a second. What's the big picture impact here? Why does this technology actually matter for our energy future?
Well, this chart shows it perfectly. It's all about efficiency. On the left, you have your regular energy output. But when you bolt on an ORC system to capture all that escaping heat, that's the bar on the right, the overall efficiency of the whole system just shoots up. You're literally getting more power from the exact same amount of fuel you are already burning. It's a pure efficiency gain.
So, let's boil it all down. The key takeaways here are pretty straightforward. ORC technology turns something we throw away into a valuable asset. It cranks up energy efficiency without burning a single drop of extra fuel. That, of course, helps reduce our overall carbon footprint. And, hey, since you're basically generating free electricity from heat you are already producing, it's a huge economic win, too.
You know, this quote really nails the whole spirit of the Organic Rankine Cycle. It's all about a fundamental shift in how we think. The future of energy isn't just about finding brand new sources. It's about being way smarter with the energy we already have.
And that really leaves us with a pretty fascinating final thought, doesn't it? If we can turn something as invisible as waste heat into electricity, what else that we call waste is just a resource we haven't figured out how to use yet?